From the 27th to the 30th of September 2021, the robex team from the Lapstick from the Bretagne went to the Journée drone and cap at the Vieille Perrotine on the Oleron island. During this conference, we tested different navigation algorithms on different robotic platforms. We wanted to adapt these algorithms to the local environment. 3 different robotic platforms were used. The Spébot, an autonomous surface vehicle which uses its GPS for navigation. The Robtide, an autonomous underwater vehicle designed here for stable cycles. And Saturne, a mobile vehicle which tracks a magnetometer on a sledge to create magnetic maps. The tests were made next to an old salt marsh. Before coming, we only had satellite images of the place. Yet, when we arrived, we quickly realized that this pond was shallow and full of seaweed. This wasn't a problem for the Spébot, who had enough space to turn at high speed. Its mission was to follow GPS waypoints, whether punctual points in red or GPS lines here in blue. As a result, the robot was able to go behind the islet without any collision. In the future, we plan to add a camera to the robot to estimate the inspected surface of the lake. Regarding the Robtide, we wanted to optimize its controller and its navigation strategy. What we wanted to do during this test was to make it go back and forth between the 2 shores, as you can see in this simulation. To detect the shores, the robot has an echosounder who can detect its distance to the bottom of the lake. The goal of this test is to develop simple behaviors for the robot in order to later make stable cycles, that is to say, a behavior made by an automaton which makes the robot stay in a certain zone or a certain area. Here is a demonstration of this navigation strategy made at the Pinfeld River in Brest. The robot aims to stay at half a meter of depth while going back and forth and turning right at the shores. Throughout experiments, we realized that this lake was not suitable for the Robtide. First, because underwater missions were not possible because of the seaweed. During underwater missions, the robot often crossed seaweed, which stuck the thruster and stopped the robot, returning to the surface by buoyancy. Therefore, we decided to switch for surface mission, which made the robot go slower and it needed more space to turn. We were able to make some cycles, but again we faced another problem. As the lake is flat, it was difficult to select a threshold for the echosounder to detect the shore at the right moment. As a result, the robot often beached himself on the other shore, and we had to bring him back with a kayak. Finally, here are some photos of Saturne. The navigation algorithm was made by students from the Bretagne. We were testing this code while reading it.